Yeah, hi there. Good day,
Yeah.
everybody. I brought a presentation as well. What is Kraftblock? So first of all, I'm Cedric. I'm responsible for communication here at Kraftblock. And as you can tell by the name, we are sitting in Germany. And what we do is to decarbonize heat. And you've heard a bit about air conditioning now, but we have a little bit different in mind. Did you know that over 50% of the global energy is demanded as heat, and it accounts for 40% of the global emissions? Most of it is in the industrial sector, from food to steel. And what we do is take either waste heat or renewable power, store it to make it available flexible in our thermal energy storage, and deliver it to either the district heating network, to the industry itself, or even to generate power again in existing infrastructure such as coal or gas-fired power plants. So our core product is the storage and the engineering system around it, because the storage alone is pretty much a dumb box who can do nothing if it's not integrated in a use case. So for example, taking renewable energy when it's available or very cheap, which makes a business case, store it for the continuous application in an industry, such as, for example, drying vegan mushrooms. I think there's a use case there, definitely. Or, for example, in the steel industry, you have a lot of waste heat. About 50% is wasted, which can save on primary energy use and thus avoids emission. A bit about our storage, which is our core technology. We have developed our material for years. So we've been founded in 2014. We had a big development phase, and we have a stable material that goes up to 1300 degrees C. What we do is we put it in a box, basically the dark box as you see here, which can be scaled by simple copy and paste principle. We store between hours and up to 2 weeks. So if you heard about the time we call here Dunkelflaute, which is the time where no wind is blowing and the sun isn't shining, this is the space we can bridge over. Especially in our material is that it's recycled up to 85% from steel slags. Steel slag is a byproduct of steel making, and it's very cheap because it's just sitting around in landfills, but very durable. So we tested it for 15,000 cycles. Just for comparison, the battery storage has about 10,000 cycles before it needs to get changed. And if you use our system once a day, it makes up over 40 years. What do we do with it? So this is what we call net zero heat system. It's taking renewable power, converting it to heat, storing it as heat, and deliver heat to as many processes as you can think. This is the Volt project. It's in the Netherlands with PepsiCo and the Dutch energy supplier Eneco, where lace chips are produced for 8 European countries. Just so you know, there's about 400 tons of potatoes going in every day, 1 million bags of chips. And chips are very energy intensive to produce because they need to be fried at up to 300 degrees C. This means 24/7, this runs with a gas boiler. And what we do is take our system, convert green power from wind turbines, and install a storage to match cheap power and their demand. We replace a 22 megawatt boiler. We save in the first step 4.5 million cubic meter of gas, which equals 8,500 tons of carbon dioxide emissions. So we deal in factories and processes as far as in perspective of our scope. For waste heat recycling, which is very interesting for steel, glass, ceramic, and cement, we have a couple of projects. This is our pilot established in 2019 in the ceramic industry, where they have a batch process, meaning they burn something, then they need to change the equipment they need to burn. And in between, this process loses a lot of heat, and they need to preheat the oven again, which they now do from our storage system, which saves the gas to preheat. This is a plant we are building right now in India, in the steel industry, where we are in a sinter plant, collecting waste heat and using it again there. And this is a EU finance project where we are taking flare gas. So if you ever saw a steel industry, there's a big flare there up in the air, burning valuable energy. And this energy is actually so big that it could provide energy and heating for millions of households in the EU. And what we do is we really try to get those 1100 to 1400 degrees C tested and move to our own production hall to replace heating. This is already it. This is my contact info, which I leave here and on Slack. And I'm sure there are some questions.